Hello, this is a video on the natural exponential function. Well, what is that? Well, it's basically e to the x. Following James Stewart's calculus textbook, he does a very interesting thing in this chapter 7 of the 6th edition. He treats natural logarithms, exponential functions in one section from a more intuitive pre-calculus perspective, and then like he does, let's do that again, and he does it the asterisk sections, 3 sections, where he covers them from a more I'm a math major kind of rigorous perspective. So 7.2 in the asterisk way through it, he defines what the natural logarithm is. So now in 7.3, we're going to talk about the natural exponential function, which is e to the x. So I've divided this 7.3 into 2 parts. This is the first video defining the natural exponential function. Okay, so the previous section talked about the natural log, ln of x. And because the natural log is a one-to-one increasing function, you know, it passes the horizontal line test and it's completely continuous. We know that it has to have some sort of an inverse function. So the natural logarithm of y equals x has to have some function. What is it? Well, that's what this video is about. It has to have some inverse function that basically, if you switch the x and the y around, you know, it works like this: y equals other function of x. All right? So let's figure out what it is. Oh, I'm so nervous. What is it going to be? It's going to be e to the x, you know, natural logarithm, e to the x. It's their inverse functions. Okay, I gave it away. I can't. You know, don't go to a movie with me. Okay, so if this is true, then we can say that there are cancellation equations. That whatever this function is of the natural logarithm of x, it's going to, you know, end up as just x. Similarly, if you take the natural logarithm of whatever this mystery function is, it's going to end up as x. Okay, we know those cancellation functions work if they're inverse functions. So, okay, now here's a quick proof of what it is, or a discovery of what it is. Now, if we take the natural logarithm, so we're on this side of this thing here, if we take the natural logarithm of e to the r, if we use the rules of exponents that were in a previous video from the previous section, then we know that we can pull the r out in front. The natural logarithm of e to the r equals r times the natural logarithm of e. And since we know that the natural logarithm of e is 1, this becomes 1 and we're left with r. So look at this. It's like this. Natural logarithm of this pulls out the x to r. And oh, okay, we found it. Yay! So it turns out that what this function is, the inverse function is, it's e to the r. Okay, so we can say that this is the inverse function relationship. You could just memorize it if you didn't follow any of that. And that is that the natural logarithm function and the natural exponential function, e, this is the natural constant e, 2.718281828, blah, 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 that e to the x equals y is the inverse function of the natural logarithm of y equals x. Back and forth, back and forth. Therefore, the cancellation equations work, right? If we do e to the natural logarithm of x, it's going to be equal x. X is always going to be greater than 0. And then also, the natural logarithm of e to the x is going to be x for all x. So these are the inverse functions. So you heard it here, the natural logarithm function right here and the natural exponential function are inverse functions. All right, so just taking care of business, limits of the natural exponential function. Let's start with this one. What is the limit of e to the x as x approaches negative infinity? Well, if you have a negative power, you flip it good, right? A negative power means you put it in the denominator. So this is, as x approaches negative infinity, it's 1 over a larger and larger number, right? And so 1 over a larger and larger number, that's a fraction getting smaller and smaller and smaller and smaller. And so the limit as x approaches negative infinity of e to the x is 0. By the same token, e to the x itself, when it's positive, that's just getting bigger and bigger and bigger and bigger and bigger and bigger. And so the limit as x approaches infinity of e to the x is infinity. Okay, check that off the list. And now, lastly, the laws of exponents, which are, as it turns out, the same as any kind of, I think actually the next section is going to talk about this sort of thing in general. But there are proofs in the book if you want to learn the proofs. They're right there. But basically, e to the x plus y is the same as e to the x times e to the y. Okay, which is a lot of e. But anyway, same thing. E to the x minus y is going to flip the y, right? E to the x over e to the y. Lastly, if you have e to the x raised to the r, that's the same as e to the prescription, rx. Ha! No, e to the r times x. All right, some laws of exponents. This has not been a long video because I wanted to chop up this section into little meaningful bits. And so we are now done with the first part, the first video on this section on the natural exponential function.